Good day everyone. Now, we are going to discuss the one of the functional group in which the aldehyde. An aldehyde is a carbonyl containing organic compound in which the carbon atom has at least one hydrogen atom directly attached to it. The remaining group attached to the carbonyl carbon atom can be hydrogen, an alkyl group, a cycloalkyl group, or an aryl group. Aldehydes is pronounced as aldehydes. Aldehyde is responsible for the odor and taste of nuts and spices. What is a carbonyl group? Carbonyl group is a carbon atom double bonded to an oxygen atom. Aldehydes, ketone, carboxylic acid, amide, ester, and alkyl halide are part of a carbonyl group. Now, let's move on in naming nomenclature for aldehyde. In naming nomenclature for aldehyde, we have the rules to be followed. The rule number 1 is select as the parent carbon chain the longest chain that includes the carbon atom of the carbonyl group. The rule number 2, name the parent chain by changing the E ending of the corresponding alkane name to AL or AL. Rule number 3, number the parent by assigning the number 1 to the carbonyl carbon atom of the aldehyde group. And the last rule, determine the identity and location of any substituent and append this information to the front of the parent chain name. Let's try to look at this example. How we're going to find the IUPAC name of this line angle structural formula. So as the rule stated, the rule number 1 is select as the parent carbon chain the longest chain that includes the carbon atom of the carbonyl group. So as we can see, this part is the carbonyl group, right? So we are going to start the numbering here. So this is carbon 1, 2, 3, and 4. So since we have 4 carbon, we are going to use the prefix but, right? And add A and E because it is only a single bond. So the rule number 2, name the parent chain by changing the E ending of the corresponding alkane name to AL. So, in identifying aldehydes, we are going to cancel this E here and add AL. So the word butane became butanal. Now, the rule number 3 is number the parent by assigning the number 1 to the carbonyl carbon atom of the aldehyde group. So since we already have the numbering, the number 1, 2, 3, and 4. The rule number 4 is to determine the identity and location of any substituent and append this information to the front of the parent chain name. So now, since we have a substituent here and it only consists 1 carbon, we are going to use the prefix meth. And add YL, so this is gonna be methyl. So in naming this example line angle structural formula, we have 3 methyl butanal. The 3 indicates that methyl is located at carbon 3, and the but indicates that there are 4 carbon, and add Al to identify that this example is an aldehyde. And we're done.
Now we'll proceed to the second example. So this example is a condensed structure formula. So the first rule in naming aldehyde is first we need to locate the longest carbon chain. So we will simplify that it is the first carbon because the carbonyl group will be considered as the first carbon. So second, third, and fourth, and fifth. So since it has 5 carbons, so we will put the prefix pen and put ANE to identify that it is a single bond. So now we will cancel E and put AL to identify that it is an aldehyde. So the next rule states that we need to find the substituent. So the substituent here has 2 carbons, so it is F. The prefix is F, and we will put YL to identify that it is an alkyl group. So now we will proceed to where is the substituent is located. So the substituent is located at the carbon 2, so we will put 2 here. So the name for this structure is 2-methyl pentanal. So 2 indicates that the substituent is located in the carbon 2, ethyl because it has 2 carbon, and pen which is there are 5 the 5th longest carbon chain, and it indicates that it is an aldehyde.
So next, we are going to draw simple aldehyde containing molecules. And the given is 6-amino 3-hydroxy-octanol, and we were going to draw it in a line angle structural formula. So the rule number 1 states that look carefully at the molecule name to determine how many carbons are in the main chain. Since it has the prefix of, so we must put 8 carbons, and it goes like this. In step 2, make a carbon at the terminal end of the chain into a carbonyl by double bonding it to an oxygen. Since it is an aldehyde, so we must put the double bond here and put the hydrogen here. So second, we must identify its substituent. Since the substituents are located at 3rd carbon, so we must count it 1, 2, 3, 4, 5, 6, 7, 8. Since this structure have 2 substituents, first we must identify the hydroxy group. Since the hydroxy group are located at 3rd carbon, so we must put it here. OH indicates that it is an hydroxy. Second, we must identify the second substituent. Since it is an amino and it is located at 6 carbon. So 1, 2, 3, 4, 5, 6. So you must put it here. So now we're done. So this is the line angle structural formula of the given 6-amino 3-hydroxy-octanol.
And that's it on how we are going to name the nomenclature for aldehyde and how we're going to draw the different structures. I hope you learned something. Thank you for watching.